So today we'll be talking about the roadmap to machine learning, the roadmap that I followed when I was in my B.Tech, when I just started doing or started learning about machine learning. So that roadmap I'll be showing it to you today. But before going into the roadmap, let me just give a disclaimer that this video is only for beginners and it's not for anyone who did anything related to machine learning earlier, because you'll already be knowing these things. So this video is only for beginners, and if you're not a beginner, you can just quit right here. This video is not for you. So for beginners, we can get started. Firstly, my name is Aditya Anand, and currently I'm pursuing M.Tech at IIT Kharagpur. So let's get started. First question that comes to mind is, how can we start? We know that we need machine learning. We want to do stuffs related to machine learning, but how to start? So the first approach that I followed long back was hit and trial method. I had no understanding of what actually those machine learning models used to do internally, but I just followed a hit and trial method. Like, I used to try all the models on data and see which model is performing good. Then I used to pick that model and improve its and try to improve its accuracy. So I will also advise you to first go through approach 1. Once you are a little bit comfortable with approach 1, then go for the approach 2, that is in-depth understanding, which will require strong mathematical background, because machine learning is completely dependent upon probability, statistics, and linear algebra. So if you're comfortable with these three things, then you can go with approach 2. But first, let's start with approach 1. And in this video, I'll only be talking about approach 1. That is the hit and trial method. We don't need any maths, but we'll be able to implement. This approach 1 will help us to develop interest towards machine learning, and whenever we want to try out something, we'll search the required keywords. I will show you what are the keywords in the further slides. So we'll be searching the required keywords on Scikit-Learn and we'll be implementing it. Now, what is Scikit-Learn? Scikit-Learn is a pre-coded has pre-coded machine learning models, and it also has its implementation guidelines. So for approach 1, the only prerequisites are Python and some of the packages of Python. Apart from the general coding, it also requires NumPy, Pandas, Matplotlib, and Seaborn. And these things, I have already made a tutorial on these things, and the link is given in the description. You can check it out after this video. So once we are done with approach 1, then we can move on to the approach 2. In approach 2, we want to do in-depth understanding. We want to get an in-depth understanding of the model. Then in that case, we can follow any standard NPTEL videos for machine learning, or we can go for some paid courses. But make sure that the paid courses are good enough, because most of the paid courses, they just give you something like approach 1, which you can do it yourself. So this is a basic flow of machine learning, how we do machine learning. Firstly, we want a data set, because see, if we don't have data, what will we train or model with, right? Just like human needs experience for learning, model needs data for learning. So once we have a data, the data may be not as required by the model, the machine learning model. So we need to pre-process the data so that we convert the data that we got into the data that the machine learning model wants. And then once the model is trained using that data, we can evaluate the model to check how good our model is performing. And if the model is performing really good, then we can dump it into some hardware that we require, or it may or may not be dumped into a hardware as well. So firstly, we need to take out the data set. We need to have the data set. So from where we can collect the data? So we can collect our own data. We can have a data survey, or we can use the data collected, which is not feasible. The first point is not feasible to collect your own data as a beginner. So we'll be generally using the data collected by someone else, like the dataset APIs offered by websites and apps. Like if you want the data for stock prices, you can search on Bombay Stock Exchange or National Stock Exchange, and there you can get the data sets for stock prices. And the other two that I used to use when I was starting with machine learning was repository and Kaggle datasets. The link is given here as well. The link is also given in the description. Now if you want to watch a separate video on how to work with datasets, then that video also I have created, and the link for that video also is given in the description. You just need to check the description. Now, once you have collected the data, make sure you collect a structured data. Otherwise, it will be very difficult for you as a beginner to convert the unstructured data to a structured data. Unstructured data refers to data that are not in tabular format, that are not stored in rows and columns. Okay, like this is an example here of unstructured data. This is a log file. So this is an example of unstructured data. Also, there can be image data that are unstructured. There can be audio and video data. These are also unstructured. So don't go for those data set. Follow structured text data sets. So that you do not need to convert your unstructured data to structured data. Now, once you have a structured data, then you can apply data visualization to see if your data is having some missing values, or maybe if your data is properly scaled or normalized, because those things are required before sending your data to a machine learning model. Because if your data is not if your data is having missing values, then your machine learning model won't be able to work properly with it. It might work, it might not work. So it's better to handle the missing values beforehand. And your data should be normalized. Otherwise, the machine learning model will not give you better results. Your data should be normalized as well as scaled. So for this purpose, you can to do these things. For data visualization and handling missing values, I have already created videos for this. So the link is also given in the description, but I have not created any video for scaling and normalization. So if you just Google it, like scaling in scikit-learn or maybe normalization in scikit-learn, you'll get it. So these are the keywords that you need to search and learn about it. Okay, and don't just keep learning about it. Take up a project and try implementing these steps. Only this way you'll learn. So the next step comes is detecting and removing outliers. Outliers are those samples which do not follow the data distribution, which is against the data distribution. So we need to remove the outliers, because those samples can lead to degradation of our model. So we need to detect them and we need to remove them. So outliers needs to be removed, and you want to know how outliers can be removed, just Google outlier detection and removal in scikit-learn. You'll get it. Okay, you must be good with Python. If you're not good with Python, you cannot move into machine learning. Otherwise, you'll just keep getting the theoretical ideas and you won't be able to implement anything. So you must be good with Python, you must be good with NumPy, Pandas, Matplotlib, and Seaborn. And Scikit-learn, you'll be learning Scikit-learn along with these things. So eventually you'll get good with Scikit-learn as well, but it's not much difficult. The next thing comes is feature extraction and feature selection. I have discolored this feature extraction part because as a beginner you won't need this feature extraction, but still if you want to learn feature extraction, these the use of feature extraction is just to project data into a different space, into a more convenient space. So for this you can use principal component analysis or linear discriminant analysis, but as a beginner you won't need this, but definitely you will need feature selection. Because if your data has a lot of features, see, there is a problem with machine learning, that the complexity of your model depends exponentially on the number of features you have in your dataset. Features refers to the number of columns. So you don't want to have a large number of features. You only want to have those features that are relevant and sufficient for you to train a model. So you need to select those important features and remove the remaining, so that your model doesn't become more complex and overfitted. So for that purpose you need feature selection, and if you want to learn about feature selection, just google feature selection in scikit-learn. You'll get a lot of algorithms for that. Now, once you are done with the data pre-processing, it's now time to split the data into training data and testing data. Because see, if you have 100 number of rows, just for example, if you have 100 number of rows and you train it on that 100 number of rows, and again you are testing on the same 100 number of rows, what's the point, right? You cannot test your model, how your model is performing by training and testing on the same data. So split the data such that the majority of the chunk goes in training, on only a few portion of the data goes for testing, because training needs to be done properly, so more number of data points needs to be there in the training section. So split your data into training data and testing data. Generally, the portion in which training and testing data is splitted is 70-30 ratio. Okay, 70% of the pre-processed data goes to the training data and 30% of them goes to the testing data. Okay, now train your machine learning model on the training data and check how good is your model using the testing data. Now, this is just a view of how your structured pre-processed data would look like. There is no empty cell, and everything is well and good and normalized, scaled, and outliers are removed, and everything is done. So this here, see, each row is called a sample. In terms of machine learning or data science, it's called a sample. In terms of database management system, it's called a tuple. So we won't go with rows and tuples, we'll be calling it as samples or instances. And each column is called attribute or feature. Generally it's called a feature. And the last, not necessarily the last, but the thing that you want to predict, okay, is called your class label. This is actually the output that you want to predict. And from here to here, from company to condition, it's your input. Okay, now what this thing will be same for training and testing data, because it both of the training and testing data came from the pre-processed data, so they will look nearly the same, though their values will be quite different, but they will look nearly the same. So we need to further split this into input and output. Okay, output must be separated and input must be separated, but the relative positions must not be interchanged. Okay, so we'll split this, and to split this we can use the scikit-learn library, that is train test split. If you just search train test split in scikit-learn, you will get how can you split your data into training data into train x, train y, testing data into test x and test y. X refers to input and y refers to output. Okay, so this is how you can split. Once you have splitted, then you can feed the training input and training output into the model training model, and you can train the model. Once your model is trained, once your model is fully trained, then you can pass the testing input and get the predicted output. Okay, once you have your predicted output, you can compare your predicted output with the actual output that you have already, right? The test y that you have already, that you got from the train test split. So you can compare with this, and the better the match, the better is your model. The more they match, the better is your model. There is something also called validation and parameter tuning, but this thing is done to improve model's accuracy. But as a beginner, uh, you won't be able to do this thing. Reason is because you don't know what is happening inside a machine learning model. For that you need to follow approach 2, but for now, just for approach 1, you do not need this thing, and your model will be quite good. It won't be that bad, it will be quite good. if you are able to do all the pre-processings quite nicely. Okay, then let me tell you about what are the different machine learning models. See, we have already covered pre-processing, train test split, and data collection. We know from where we can collect data, from how can we pre-process the data, and how can we split the data and feed it into a machine learning model. But we don't know what are the machine learning models. So let's learn about some of the machine learning models now. See, machine learning models are broadly classified into two categories. That is, one is supervised model and the another one is unsupervised model. The supervised model needs the corresponding outputs, that is the class labels. That means uh, you must be able to say pre-hand that if this is the input, what is the output. Okay, but unsupervised model does not have an output. They just group similar samples together and they call it as a cluster. Like they group a few data points together and they call it cluster 1. They group similar data points together and they call it cluster 2, and so on. They have multiple clusters. So for unsupervised learning, it's k-means, a priori hierarchical k-means, and many more like this. But see, as a beginner, don't fall for unsupervised learning. Learn supervised first, because it is quite easier to understand as compared to unsupervised learning, and easier to implement as well. So in supervised learning, we have decision trees, logistic regression, linear regression, support vector machine, naive Bayes model, and don't go for the etc thing. These five are the mostly used models, so stick to these five and learn about these five only. Okay, how to implement these five? Like if you want, say, first before going to this these models, let me tell you what is regression and classification. So if your class labels, that is outputs, are continuous values, like temperature in a scale, like today is 37 degrees Celsius or today is 35 degrees Celsius, something like that. The temperature is a continuous value. Okay, so predicting a temperature, or maybe stock prices are numerical continuous values, right? So these are regression tasks, whereas classification is predicting different classes. They don't have continuous values, they have different classes. For example, uh, predicting a day is sunny, rainy, or windy. So there is three kind of classes here involved. Predicting a cell is cancerous or not. So there are two classes here. It is either cancerous or it's not. So when the classification is limited to only two classes, then we call it as a binary classification, like yes or no. Maybe the cell is cancerous or it's not. The day is sunny or it's not. Okay, but when we talk about multi-class classification, we deal with more than two classes, two output classes. Okay, like sunny, rainy, or windy, there are three classes. There can be three possible outputs, right? So there are three classes. So this is called a multi-class classification. So try to do classification, or you can also do regression, but try to start with a binary classification problem, though it will not hamper much if even if you go for multi-class classification or regression, because by the end, in approach one, you're not understanding what is happening inside a model, so you just need to implement the model. So it won't be much difficult for you to implement either regression or classification. But remember one thing: when you're going for regression, then to calculate the model's score, like how well is your model performing, you cannot calculate accuracy, precision, recall, and such things. You need to calculate R squared score, which shows that, what suppose if the data you have predicted is 37 degrees Celsius and actually it was 39 degrees Celsius, so you are just deviating by 2. Okay, so even if you deviate upper to towards the upper hand or towards the lower hand, that's like you are not deviating much. So even if you didn't predict it exactly 39, like in case of classification, if you didn't predict it exactly sunny, then you'll be getting a score of 0. Okay, so do not use accuracy, precision, or recall for regression. Use R square or root mean square error. And I've just made a mistake here. It's not RMQ, it's RMS, root mean square error. Okay, and For classification, you can use accuracy, precision, recall, F1 score, because they will be exactly matching. If you have predicted something like windy and it was actually sunny, then you get a score of 0. Okay, for that tuple only. So this is the basic difference between regression and classification. Now this supervised model decision trees work on both regression and classification. Logistic regression is for classification. Linear regression is for regression. Support vector machines works with both regression and classification. They are called support vector regressor and support vector classifier. And naive Bayes model also work with both regression and classification. So this is a basic idea of the machine learning models. Now search about them and learn about them in detail. Now the next thing that I would like to tell you to how to proceed with approach one. Okay, so firstly I already told you that don't go for unsupervised learning. So first get a structured data set that has class labels. This is just a summary of what we have done earlier. Get a structured data set that has class labels, because we'll be going with supervised learning. Pre-process it, not much but just a little, like just handle the missing values. Even if you don't remove outliers, it's fine. Even if you don't normalize or scale, it's fine, but at least remove the missing values, because most machine learning model won't work if you don't remove the missing values. Then split it into training and testing data. Train it with different supervised machine learning models, like the 5 machine learning models I have shown earlier: decision trees, logistic regression, linear regression, and SVM and naive Bayes. Train with all of them. Okay, and train, if you are doing for classification, then you train with the classifiers. If you are doing for regression, then train with the regressors. Okay, and test all the models and get the score for all the models. Now once you have the score for all the models, you can see which machine learning model is performing the best. Then choose that machine learning model and try to improve that model only, by improving your pre-processing, by tuning model hyperparameters, like changing model hyperparameters. There are many hyperparameters that you'll get when you're using a model, so change them and see what happens. Plot a graphs, check, do something, and try to improve the accuracy of the model, because other models were anyway performing bad, so they won't perform good even if after you improve something. So pick the best model and improve it, and repeat these steps. After picking the model, repeat step A and B, these 2 steps. I hope you can see my mouse. These 2 steps, repeat it until you can no longer improve. Do this for a few projects. Take for example, take up a cancer prediction project or stock prices prediction. You can find these things on Kaggle. Already some people have done it. You can learn from what others have done it as well. So it's not a bad thing that you're copying their code. Don't copy their code, learn from their code. Okay, learn how they did and what they did, learn their approach, and you can also improve on it, because you're just a beginner. You cannot think that you will be doing everything on your own. You need to learn from somewhere and from someone, right? So don't be afraid to learn it. Search like cancer prediction and stock prices prediction in Kaggle. You'll get, obviously you'll get a lot of projects related to this. And once you keep doing this for a few projects, you'll be automatically interested to move towards approach 2, that is in-depth learning, because there is nothing you can do to improve your model more. So you need to know what actually the model is doing, right? So that you can choose which model is best for which kind of data, and what improvements you can make in a model. You can only do that only when you know in depth about a model, what that model is actually doing. So you'll be automatically interested towards uh, approach 2, that is in-depth learning. But before going into approach 2, while you are doing all these things, make sure that you revise probability, statistics, and linear algebra, and you get good with it. Because in most of the tutorials, like even if you watch NPTEL videos or the courses that you opt for, they would expect that you know these mathematical backgrounds, and they will not be teaching you. So be ready with those mathematical backgrounds: probability, statistics, and linear algebra. Now, this is the final tip. We are done with the roadmap. This is the final tip. The final tip, I just want to say that use Scikit-Learn as much as you can, because it has all the pre-built models, and try to read the documentation properly. Like that if you want to implement a particular model, there are a lot of hyperparameters there, so read about those hyperparameters and read about what kind of values they take and what those values do. So you learn that way a lot. And also refer to Kaggle, because there are a lot of things in Kaggle. There are a lot of people in Kaggle who are doing these kind of things, and they have written a lot of notebooks and they share their ideas as well. So Kaggle will definitely help you to improve your machine learning skills. So all the best.